Good morning, everybody. How's it going? Right. Okay. Houston, do we have a problem? Oh, there's a build failure. So let's just quickly fix this first because something's funny's happened. It's complaining about a file not found. So I think this is going to be a trivial one. I probably forgot to commit something. Let's quickly check. Oh yes, there it is. Okay, that should be easy then. Git add. Now, to force push or not to force push, that's the question. Because there's only me here. Feeling like a cheeky force push. But if you're working in a team of lots of other developers and so on, then that might be more of an issue. But today, we can get away with force push and everything's fine. And then no one will see my mistake. So we're going to amend the previous commit and check for other. Yes, look, there's another file. Check for other accidentally forgotten files that should have been committed. See, I had ran all the tests on my machine because someone in Discord pointed out there was a build failure. I had run the test. Look, there's the tests there, and then here's all the other tests here, and everything was passing. It's just I missed a file from the commit, so it could be worse. Okay. No one saw nothing. Okay. Oops. Never mind. So I guess we'll wait for this to build. Oh, the gardeners have got their leaf blowers and hedge trimmers out today. I'm not sure if it comes up on the stream, the noise. It seems to be all right, but they're cutting and chopping away outside. All right, let's see what happens. And then we can work out what we're going to do next. Ta-da! Everything's fine. Everything's fine now. Look. Wait. Don't want to see that again. Right. Everything's fine. Right. So what happened? So yesterday I was struggling. I was struggling yesterday with the borrow checkery stuff, and I was having dilemmas about whether I should be doing modifying things in place or whether I should return in new sets and so on. And then I had my tests, which said what I wanted to do, but then when I had the implementation, it wasn't actually possible to do what I needed to do. And let's just quickly remind everybody of what we were trying to do yesterday, which was somewhere down here. Here he is. Come on, there he is. Yesterday we were trying to make this work, and I'm happy to report it now does indeed work. Happy days. But in order to do this, you needed to keep a reference to the original placement as well as the modified placement. And when I was working on stuff yesterday, I forgot to keep the original placement intact so that you could say what changed. Yeah. So that was one of the issues that I had. Then I had borrow checking issues, and I ended up in a situation where all the things I was trying to do yesterday worked, and in that I'd fixed the borrow checker issues and so on. And the way that I ended up fixing it was to store the indexes of the indexes of items that needed to be used that were in the vectors, and then after we finished iterating over it, then take the references to it, because you only needed the mutable reference while you were iterating over it. But anyway, all that turned out to be wrong anyway, and sort of moot, because I hadn't kept the original thing, so I shouldn't have been trying to modify it in place in the first place, because obviously that overwrites the original data, which you need to refer back to. But anyway, yeah, yesterday I wasn't thinking quite as clearly as I could have been. What are you gonna do? What are you gonna do? And so, yeah, where's our substitution thing gone? Yeah, where is it? EDA substitution here. This is the one. So let's have a quick look at this. It also occurred to me yesterday, as I was sort of getting a bit close to finishing it, that it was wrong for another reason. The problem was that, and I had the same issue with my old software, but it was never really a problem, but it was something I always wanted to improve. Whereby you make one substitution and then you start looking for other substitutions again, as in there is a chain of substitutions that happens, not just one. So, for instance, you could say if you see this resistor and value, then replace it with a different resistor and value, or something like this, right? And then, once you've done that, you can say if you haven't specified a tolerance for the resistor, and you see this type of resistor, then add the tolerance to it as well, right? And then at the end of all this, then you can go from the fact that it's resistor with a voltage and now a tolerance, then map it to an actual manufacturer and part number. So there's actually a chain, and now it does that as well. The integration test doesn't currently show that, so I need to poke that a little bit this morning, not too much. So the way that the chain works is if you start with a name and a value, you can then map it to an intermediate name and value, and then you can have another rule that says if you see an intermediate name and value, then you get the substituted name and value, like so. And we've got a unit test for this, and these are done in reverse order, which means they're added to the list in reverse order, which means that if as you're processing the list, you will come across this one last, and then you have to start reprocessing all the substitutions again from the beginning by putting them in that order. Yeah, and then you end up with the right thing. I also fixed up some of the naming and so on, so they're essentially like rules now. The substitution result gives you the original placement, a reference to the original placement, but because we didn't need to mutate it, it was easy to get the reference out of it, which is kind of what you wanted. Then we got a resulting placement, which is a new placement that's been modified as a result of a chain of rules. And the rules are basically just those things we had yesterday, where you've got like a dip trace exact match rule or whatever, So that all happens. And that meant that in the variant builder, we could find the placement that we're trying to print the details of in the list of substitution results, print out the original placement details, and then print out the details of the chain that caused it to be modified. And every time we do this, we step down like a new new leaf on the tree, a new node on the tree. Our integration test doesn't show more than one of these at the moment, so yeah. So let's quickly update the integration test so that it shows that, because there isn't anything currently that tests the printing output at the moment. Right, and then we'll get on to something else. What? I don't know. Maybe as I do this, I'll come up with the idea of what to do next. All right, so variant builder test. So if we say, yeah, okay, yeah, okay, fine. So we need our substitutions. Where's our substitutions gone? Right, here we go. So we've got one substitution here, which says that when you see header 2p with power, then use this. Right? So how about when we see a header black, we do that. And then here, we change header 2p power to just be header 2p black. Right? That'll do it. Then we'll have a new substitution node, which will be something like this. So it'll say this one got replaced with this because because of this. So if you see a power header, it's supposed to be black, but you don't care about the exact part yet, right? And then it goes, if you see a 2-pin black header, you're supposed to use this one. And that's made by these people, this company. So that's what we want. Let's see if it works. It might actually work. No. Well, it's close though, look. What did we do? Got header 2p power, header 2p black, by name pattern header 2p power, yeah. And we got substitute again. Name connection header black by header 2p black. Oh, no, I'm reading the wrong thing. The tree bit was fine. Tree bit was fine. I was expecting the problem to be with the tree. It's just this. Do substitution. Okay. Maybe the tree isn't fine still. Oh, it is fine. Yay. Okay, fine. So we've done that. Great. Update the variant builder to show expected output when a substitution chain is applied. Well, update next commit message. Yeah, good. Tests and everything. You do commit without tests. Coming up with a name for a commit message. Assert expected output when a substitution chain is applied. I mean, it seems fairly reasonable. Yeah. Okay. Okay, so that's all we did. There was no production code changes. It's just test code. We're just improving the test code. Because you had to iterate over the chain, even if there was only one entry in the chain, regardless. I mean, you didn't have to. You could just get the first thing from it and print it out. But when I coded it up yesterday, I just coded it right the first time, apparently. All right, so that's done. And we're going to go, I'll go test dash features equals clear. Everything passes. No force pushing. There you go. All right. Next. So I drew a little diagram yesterday of where we're sort of at with all this thing. This is what it looks like. Yeah. You just pull that over this way a little bit. That's better. There we go. So this is sort of the state of this whole sort of processing stuff at the moment. And as you can see, we've built quite a bit here. There's quite a bit. So we start with the EDA placements to remind ourselves of what they look like. Here's some EDA placements, right? And then you get an assembly variant, which is a list of reference designators and a name. And then you get a bunch of substitutions, which you need to process all of them for every single placement until you can't process any more. And then you use the results of those substituted placements with a bunch of part mappings which refer back to some parts. And you use the current state of your machine's loadout in order to apply mapping rules, which then gives you placements that are mapped to manufacturers and part numbers. Okay, that's pretty good. That's what we've done. So one of the things that occurred to me based on my experience in the past with doing some of this stuff is that when you've got a machine and it works, pick and place machine, and it works, you don't want to mess around with it too much. And sometimes you need to unload lots of things from your machine, build some other projects, then come back to your machine. A bit overexposed there. Come back to your machine. I don't know why it suddenly decided to do that. Oh well. There we go. Come back to your machine at a later date and then make the same thing again. And knowing that it works the first time and how your machine was set up the first time, you know, like where everything was in the machine, is useful. It can depend on the machine somewhat as to whether this is a good idea or not. But one of the things I thought was that it might be useful to remember the loadout of the machine and where things were when you want to build the project again, so that you can put things back in the same places. But I don't think we're quite there yet, because we haven't got the concept of like feeders and all this kind of stuff yet. And the loadout, it's currently what's in the machine, but it can also sort of refer to a historical list of what was in a given feeder, based on the feeder name and whatever. I don't know whether this is going to be useful or not, because sometimes your machine sort of like they sort of like have their sort of like ongoing life, as it were. As in, you put a component in the machine and ideally you leave it there and never touch it until there's no room to put anything else in the machine, and you have to take it out. But at some point that you want to put that component back in, it's nice to know where it was in the machine. So the way I used to manage that myself, let me show you my feeder layout. Here we go. The way I used to manage that myself was that I used to create the definitions of, define the feeders. And this is just in a, spreadsheet. And then I would I'd tell it which feeder number it was in. And if I took that out, I would then disable it by putting an exclamation mark in this flags thing here. And then if I ever needed to use that component, I would then search for the component in this list, and then I would see if I could put it back in the same feeder or not. So that's what I used to do there. There's some concept of loadout and sort of loadout history and things like this is required, and there are reasons for doing this as well. It's not just that it worked there, so put it back there. Sometimes you put a feeder in a machine and it just doesn't work in that feeder for whatever reason. Maybe the tolerances for that feeder aren't quite right for the for the cut tape or the plastic tape or the peeler or something daft, or maybe it's the tape is a bit wide and that feeder slot is slightly narrower when it was made. It can be weird. Sometimes some things just don't work well in a given feeder. So it's nice to know this. Yeah. So I quickly wanted to talk about that feeder loadout, but I don't think we can do much with it today. Don't think we can do much with it today. Right, let's go back to this. So at the moment we've got our map placements, and all we do is print out a tree. We don't actually do anything with these placements afterwards. So, I mean, we're sort of getting through some of this workflow stuff at the moment. It's good. We haven't dealt with stock yet either. We haven't dealt with stock. Where do we go? Because if you've got multiple parts, right, and both of them match, as in you've defined the part, both of them match, there's no point. You can't use it unless you've got enough stock. Yeah. So stock or map placements. I think what we should probably do before we come down to the stock thing is write the placements file back again, but with manufacturer and part details in the CSV file. That's what I'm thinking we should do. Um, hmm. Let's have a think about that. Let me think about that. Right. Let's deal with that. Right. Let's see what we can find. So we've got our tool. Let's have a quick look at it. Let's have a quick look at. Let's close everything first. Close all tabs. So yeah, we've got our process result. We build a mapping tree. We've got some match mappings and so on. So it feels like here we should write out the EDA placements along with. I mean, do we need to do that? Do we need to do it? Do we need to do it? Let's have a look. Do we need to do it? I mean, our tool doesn't really do anything other than try and map things at the moment. But are we going to need it? Are we going to need it? Well, I mean, what's the next step of this process? We've got placements and mappings. Let me think about the data that we've got at this point. have we got? So we printed out our tree. We've got this and we've got this. I mean, the main thing is this. So we go over, we've got this mapping result. Matched mappings. And the match mappings contains the updated placement. And let me look at the tree again. And it contains this. In the mapping. It feels like we need some intermediate no, maybe we already have it. It feels like we should probably have some intermediate. Yeah, I think we should do this now. Because at the moment we've got this, we've got the placement, and we've got a bunch of rules that potentially were applied to it. But at the end of the day, what we need is just one thing out of it. So we should probably try building that and writing that to at least to a file. And then later we might decide that we don't need it to a file. But at that point, at least we've got the information out of it that we want to actually have the pick and place machine actually place. Yeah. Okay. Let's do that then. So at the moment, if it's okay, mapping node. In the case where it's okay, there should be only one. And it would be a problem if there was more than one, but it's okay. It's okay. So this is the tree bit. So, okay, let's define what we want in the test. So we've got this. Now the question is, do we want to write out the pick and place file in the same format as the original one? Or, regardless of which EDA tool it was, do we want to write out our own thing? I don't really want to write out a EDA specific file. That's my first thought on it. Other things that are in this EDA file are like the side that it's on, the rotation, and a bunch of other things. And each EDA tool has its own sort of quirkiness that I know we need to deal with regards to this. And like we need to normalize our data. So for instance, rotation, it's like, you know, do we want to have rotation values higher than 360? Do you want to have rotation values only between 0 and 360, or do we want to have minus 180 and 180? Who knows how we want to do all this, right? But we want to normalize it somehow. And I think as part of reading in the EDA data, it should be normalized when it's read in, probably. Let's have a look at one of the EDA placements for a moment. Because we've got the CSV record and then we've got the EDA placement, right? So we've got the CSV record, and this is the one that's going to have like all the size and rotation, sorry, side and rotation, and XY coordinates as well. And then we have the actual EDA placement, which has got some details. Now, currently we have some details and they're stored in like an enum variant. Now, question: should we be doing that, or should we now come up with our own placement thing, or should we do it before? Oh, I don't know. Don't know. Where does the normalization happen? Do we want to keep the EDA placements with their details exactly as is for a while in the system and then normalize it afterwards and then write it out? I guess we're going to need to have a reason for doing it one way or the other before we do it, rather than just guess. Because if you guess, it's normally wrong, which at a few of these live streams that I've done so far will be a test to. Where I've guessed and it's been wrong, and then I had to come back and change it. Okay. Let's just keep it simple for now, and do it in a way that lets us not have to care about solving that issue. Let's just say that we're going to read in a CSV file and check its content is whatever. Let's say the expected CSV file for this stuff up here is going to look like this. When I'm trying to find where to put it, and trace logging. Yeah, and let expected no, I'm going to say normal. I don't know. I don't know expected CSV content, because maybe we don't need this, you see. So I don't know. Why am I doing it if I don't know I need it? Because we know that we need at least these things later on. Okay, we need a ref theds, we need a coordinate, we need the side, and we need the manufacturer and part number. We need these things. So let's start with the ref des, the manufacturer, and the part number. And we're going to use this indoc macro to do it. And it looks like this, I think. Like this. But without these. So let's say it contains ref des like this, and manufacturer and MPN like this. Except we need to escape these. Yeah, we're going to need to escape those. There's no comma at the end of a line in a CSV file. So let's deal with the first one. So what we want is R1. Don't need that. Let's build a little template first. Right. We've got R1, R3, R4, J1. R1, R3, R4, C1, J1. R1, R3, R4, C1, J1. And it's going to have this one because of the rule. Plop. With a value of res 2. And then we're going to have... Well, it's not going to have this in it, is it yet? This is a bit weird because should we be writing a CSV file that's incomplete? I'm going to say yes. We can decide later if that is true or not. But what I want is the data structure that contains the information. That's what I'm interested in. R4 can't be in there either. Okay. C1 can't be in there. But J1 can. Right. There we go. So we've got a CSV. This is what we want. So let's add an assertion to read in a file and verify its contents. There was a thing we did the other day, which was like some assert fs thing, wasn't there? Yeah, this thing. Is it this? What is it? You just create. Let's go back to the README. We already had this. Oh, it's one of the next problem we're going to have is like where to create the file. We're going to need an argument to tell it where to create the file, aren't we? Yeah, so we do need to tell it to create a new CSV file. Yes, we've already got a tempter in our test, I think. Come back to that. Because we've got this build temp file. Yeah. We can use this. we're going to need the argument for this thing. And this is going to be the CSV output path, perhaps. I'm going to say output. We'll just call it output for now, I suppose. We can always change our mind later. And this is going to be output.csv, I suppose. At which point we can use build temp CSV file because we've already got it and we don't need to specify the file extension because we did that already. Okay. So we've got this thing which we can now add here, I suppose. And then we can assert it. Let me think about this. So we get a path buff. But this, not sure what child does. Oh, I didn't know that. I didn't know you could do that. I'm not sure this API is the same one that I'm thinking of. Tempter, where's that? That's in temp file. Is there a child method on this? Let's have a look. No. No, there is not. So it's a different temp thing. Okay, we'll deal with it a different way. Let's see if we can work out how to do it. Cert fs, cert. Named temp file, that was it. Yeah. So this is from another one. And this is... Have a look at this. Yeah, apparently that's what we need. Sure. And the name of this was our output, test CSV output. And then we can go assert EQ CSV output file dot. Right, how are you supposed to do it? Oh, you just go assert on it. Okay, fine. But you're supposed to use what predicate? And then what? Diff. And then we say something like expect CSV content, perhaps? Maybe? I don't know. I don't know. No. Oh, you have to go unwrap, though. Okay, so apparently not that. Oh, wait. Oh, just need the... But is this the right thing? I'm not sure. I'm not sure that that's exactly correct. Are we asserting the content there, or are we asserting that the something on the file? It's not entirely clear from this README, because this example is not particularly helpful to me. I mean, it's like I can sort of see what it's doing because it's touching the file, which should create the file, but then not put anything in it. And then is this asserting that the content is this? That's how I'm interpreting this example. But it'd be helpful if this was named, perhaps. I don't know. I don't know. I haven't turned my chat thing on. Oh, here we go. Hi, everybody. Here we go. Let's have a look. Awesome. Right. 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 Okay, so close everything else. Run it. Okay, so it fails. Now it should fail because it doesn't understand the argument. Yes. Okay. So we're gonna add the argument like we did all the other ones. We're gonna come back to our build command. And we're gonna specify output file. Why not? I'm not sure about this value name here. Not sure about this value name. Seems a bit funky. Let's have a look. Hubba. Right. Okay. Let's run it again. Yes. That's fine. Right, so we need to use the output. Yeah, okay. I'm not sure it should be called output. So we've got build assembly variant and we've got output. Let's call this output file. No. Don't need to think about what it's called there at this point. It's only when you need to say write a CSV file that do you actually need to know that it's the output refers to a CSV file. Okay, so that should break this other test. So now we've got our output thing. Okay. Substitutions output. Okay. And then we're going to need the output file on the tool. Plop. Right? And that should fix that one, but the other one should still be broken. Yep. Okay, so now it just doesn't, yeah, cannot find a file. So we're not writing a CSV file. This is good. Progress. Let's write a CSV file. Woo. Right. We don't care about the EDA substitution results at this point, but what we do care about is this match mapping stuff. So let's say write output CSV. Let's do that. And then we're going to say question mark because it could definitely fail. Because, you know, file system stuff, right? Create function, right, output. Here we go. So, yeah. Right, what's this? This is the output file name. Sure. And then this is the, what, match mappings? I'm not sure this is what we actually want to do here. Do I want to pass the match mappings to it? Or do I want to pass in EDA placement mappings? Because the match mappings was used to build a tree. Yeah, I don't like this. I don't like this. I don't like this. I don't like it. I don't like it. No. No. Oh, this is the wrong kind of thing. This is supposed to be... No. It's supposed to be an anyhow result. Of something. I don't know what yet. Sure. So CSV output, and then we want to have something which we can then just do other things with. It's sort of like the goal. So we need to get from this match mappings to something we can put on a pick, you know, put something we can use in job. Let's say placement map. Placement mapping. Because there needs to be a one-to-one relationship between everything. Right, but we don't have that yet. So let's say let placement mapping is build placement mapping. We've got this part mapper. Arguably, the part mapper could be updated to give us this. Let's think about this. So we give it variant placements, part mappings, loadout items. Then it gives us back a result of placement part mapping results. Yeah, I'm going to keep it in a separate thing for now. I don't know what I'm going to call this, but I don't want to put it in this. I want to put it in some other structure that I can call a method on easily and debug it and whatever. Let's say part mapper, build placement mappings, and we give it I suppose we need to give it the processing result, really, don't we? Because it shouldn't process this matched. Well, or should we? Maybe we should. Yeah, it should be the match mappings. Regardless of whether there's an error or it's okay, we still want to write the CSV file. That's what we said. So let's pass it match mappings like this. And then we're going to get some placement mappings for everything that was okay, for everything that was mapped. It seems fairly reasonable. Okay, let's make it happen. Here we go. Can it fail? No. It can't fail. All it's got to do is give you a list of stuff. What's it going to give us? It's going to give us a list of... Well, it's going to give us a vector. Now, I did read something the other day about not using a vector as the input to things. If you're using an immutable vector. I read that you should probably pass a slice in. This is what I read. And then when we do this, we should go as slice like this. Apparently, this is better for a few reasons. Right, so we're going to create a vector of something. And this is going to be matched mappings. And it's going to give us a vector of some stuff back. Not sure. What do we want to do? We want to write some things to a CSV file, don't we? So the things we want to write to the CSV file, let's look at the test, aren't placements. These aren't placements because it's got this. This is part of the placement. We've got an EDA placement and then we've got a placement. Do we create placements at this point? I feel like perhaps we should. Or no, I don't think we need to do this just yet. Let's create a structure called placement mapping. In it, there's going to be some stuff. One of the things it's going to have is EDA placement. Another thing that's going to have oh, the gardeners are getting pretty loud. Hold on. Oh. They're right outside the windows. They've got one of the strimmers. They've got one of the strimmers, it's a gasoline powered strimmer. Well noisy those things are. Right. So you get placement mappings, you write to CSV file. Let's have a look at the part mapping result thing. Match, yeah, this thing. So this takes placement part mapping result. I mean, because this is the vector of stuff, right? And it's not necessarily the first one in it that's the actual one. What we want is the thing out of the part mapping. We want a part. Of course we do. It's funny how you can't see the wood from the tree sometimes, isn't it? But so if we go back to here, no, not back to here. Where were we? Here. And we want a part. Let's say we want that. Now, I don't know whether I want references to these things or I just want to clone them. Let's just go with not references to start with. So you get a list of these back. That looks good. Right. And then we're going to have to do some similar processing to the kind of processing that we did in our tree building thing, where we have to iterate over the list of stuff in this matched mappings, and then if there's only one thing that's applied and it's okay, then go into it and find the thing that was. Yeah. I mean, but do we already have this? Like, it's like we're applying rules, and then it might be okay. And then it's okay, get a mapping error. Let's keep it separate for now. Keep it separate for now. Okay. So it feels like we need a test for this, a unit test for this. We'll play some mappings. So we've got this process method, and it's got a test. Right? These tests have got some expected results in them. Which we can look at to decide what we want. So we need a certainly need a placement. We need a mapping result. We need a part mapping. We need applied rules. Yeah, it's quite a lot. Let me go back and look at the process method again. So I'm having second thoughts now. There should only be ever one rule to pull something out from. I mean, because if we looked at this, yeah, but we've got multiple ones. It's not what we want. Yeah. See, this thing has all the knowledge of what it needs in order to return the result, right? This is what I'm thinking. So we could use these matching results to create this this thing as well. I mean, it's called process. It is processing. You see here, part mapping result. This thing is a vector of these things. Let me look at this again. I think perhaps the part reference could be put onto this. Yeah, I think that's probably what we should do. And then we don't need this extra method, and then we don't need to recreate the results from the previous one and have all the weird edge cases and all this kind of stuff. I think it's probably better to put that in this part mapping result. Wait, placement part mapping result. Yeah, I think that's where it belongs. So it was okay. Okay, that's what we're going to do. I've decided. So we're going to get rid of this, but we're going to make this return option because it might not be mapped of a part. Now, do we want to copy the part or do we want a reference to it? I'm going to go with creating a reference to start with, and then if it doesn't pan out, because the mapping has part. So this really is part. Let's say it needs the same lifetime as the mapping. Okay. All right, let's run the test and see what happens here. It's going to be compilation errors, right? Part mapping result. Let's deal with a happy case first. So map part. We've got a part. So in this, we want a reference to the part that we're supposed to map to, right? That seems fairly reasonable. Yeah. Then we're going to say I'm going to put it at the start so I can see it. Part, and then it's going to go part 0, right? Oh, some reference to a thing. Right. That's what we're doing. Right, hopefully that's a bit clearer to everybody following along now. And then it's going to be the first one and the second. So that's that test case dealt with. This one. It's going to have part none. Because multiple matching mappings, you can't map to a single part. Map parts with no part mappings, you definitely can't map to anything because you've got no mappings. Right, part none. Right. And then this will map parts with multiple matching mappings with one in the loadout. So here, we should have one. So this should map to one part that's in the loadout. The second one is the one that was there. So it's supposed to be part mappings 1, which referred to this part. So this is going to be some that part. Right. And now where we create the mapping result, we don't have the thing. So let's say the mapping result and the part is a result of this stuff. And it's going to be none. None. These ones are all fairly easy, right? But this one, not. This one's going to be different. It's going to be some part. But we don't have a part. Let part. And let's just create a temporary one. Oh, it needs to be a reference. No, let's not do that then. So this part needs to be some part mapping result. Oh. Oh, this is non-trivial. Damn it. Right. Let's just write something in here to start with, and then we'll deal out with the. Okay, we're going to need to go part mapping result dot filter or find. Yeah, find, because there's only going to be one. Oh, we need a. I always forget to do the iter on this thing. Dot part mapping. So apply where there is an applied rule. That's the one we want. Right? And then from that, we unwrap it and we get the part mapping, and then we get the part out of it. Boom. Okay, that kind of works. I don't know what happened here. This is supposed to be some part here. And then I've got some brackets here. What's going on with the brackets? Am I missing a bracket? What's going on? We've got this bracket matches that. This bracket. Supposed to be there. This one. Supposed to be there. Right, there we go. Right, so now we've got the part, which means we can put the part here, right? That might work. Close. Close. Okay, so map parts with multiple matching mappings in the loadout. Maybe I've got the multiple matching mappings in the loadout wrong and I referred to the wrong part or something. Probably what happened. Let's have a look. So we've got a placement. We've got a part mapping result. And then the part that it's mapped to. Yeah, I've just got the test set up wrong. Due to probably the ordering of these and fuzzling me to start with. So we're saying that when you've got R1 with name and value, and you've got name and value both defined as part mappings. So the name and value maps to both parts, this one and this one, 1 and 2. Right. But this one is in the loadout. Then we're supposed to use this one, which is the second one. Okay. Cool. So, yeah, that's better, isn't it? That's better. All right, so now we go back to a binary thingammy-jiggamy. And our match mappings now has got parts in it, which is what we want to use when we're writing a CSV file. Yeah. Okay. All right. All right. So, yeah, let's make this happen. So now we can get the parts out of here and write the data from it as is appropriate. So, yeah. So now we need to do CSV writing in this. And we've already got code for CSV writing in our tests where we create CSVs. So we can just grab it, right? Yeah. We need to create records. Let's see where we do this. Yeah, this was it. We have a writer and we serialize stuff. And then we flush stuff. So let's borrow some of this code for the moment. And then we need a record that we write. So we'll borrow this as well. And we can just inline, oops, daisy, inline that into there for now. Right. And then we're just going to go record like this. And we'll deal with this later because I don't know what to call it right now. And what we said we wanted to write in our test was the ref there's the manufacturing part number, right? So ref there's manufacturer and NPN. And we want to use Pascal case for it, so we're fine. And we said we want quotes, so I'm going to do that. And we need an output path. And in order to do that, we create a path buff from the thing. Leave. So we've got output path, we've got our record that we're going to serialize. Then we create a writer. And then we need to do stuff in a loop. So we have to use for matched mapping in mappings dot iter. Right. And then we need to return OK. But this is no good. This is all. Let's create the record and fill in the things from the matched mapping. Okay. So we have to go if let, I don't know. Let's go matched mapping. Placement part mapping result. If part. Oh, you can do thumb like this, I think, can't you? Something like this. I'm not sure about the destructuralizing. And then we need the rest of the fields, I think. Yeah. And then we can get the EDA placement dot refdes, and then we can pull out the part. Yeah. That didn't work. Can we not go some parts like this? Oh, wait, perhaps you can go if part dot is sum, like this. And then you can go part dot. Yeah. Let part is part dot unwrap. Part dot manufacturer and part dot weapon. Then we've got this EDA placement. Why is this no. No. What have we got? Why is it moaning? So we don't care about the part map. We don't care about the mapping result. All we care about is the EDA placement that's in this. Oh, okay. Let's. No, it already is one of those. Let's see what the errors are. I don't know what the errors are, right? I don't know what the problem is right now. Oh. Yeah. Oh. Yeah, it's going to say it's not used. Yeah, and we need to clone that and this and this. There we go. Unused variable. So we've got this unused variable here. Apparently there's a different way of doing this, which is like comma dot dot or something. We don't care about the other things. Yeah, okay. So then we've got unused mapping result. And we'll do the same thing here, I suppose. Comma dot dot, right? There we go. Okay. Who thinks the test is going to pass now? I mean, it might. It did. Love it when it works first time. Brilliant. Oh, that's great. It's fantastic. Fantastic. Happy days. Happy days. Okay, let's go back and look at the test to see what we missed. And probably do a commit at this point as well. So, tell you what we're going to do. In the test, we're going to print out the content of that file. Now, how can we do that, though? Because yeah, you can read a file to a string or something. There's some silly method to let you do it. But I don't remember what it was called. Because we don't really want. I want to print it out as well. Are we doing that somewhere else? Haven't we already done that? Oh, hi, Commander Guy. I didn't see you in the chat thing there. Oh, it's only 10 minutes ago. I was quite focused there. Yeah, it's going good. I fixed the build failure you pointed out. Thank you very much for that. You can see the start of the stream to see why it happened. But it was just a couple of missing files. Nothing too serious. But we're making good progress today. So we want to get the file, and we just want to dump the content on the screen and then do the assertion. We don't want to have the assert read the file. Let's have a look at how assert is reading the file. Yeah, not happening. But it's got this I where I into path predicate. We can look for the implementations of this. and then it's a string, and it goes into path. And it creates a new predicate from itself. But predicate is... Where's this? I see. Well, content. I kind of just want to know where it reads the content of the file. I don't really want to sort of dig around this library of stuff trying to work out where it is. Yeah, you could be there for a while. I mean, there's file here, but yes, do we do? And I don't want to. I don't care. Let me have a look at assert. Does this? What does it take? I mean, it's just an expression. Interesting. Okay. Oh, look, I've got a typo. Output content. File? I don't know. Let's do the Google search because there's 1,000 ways of doing it. Let's go Rust read file into string. There it is. Look, read to string. And you just give it a path. That's what we had, wasn't it? Read to string. No. So then we're going to go print then. Isn't there a way of doing that without the formatting thing? And then we need to somehow do the same assertion, right? But do we want to do it like this? Can we just go... Can we use this? Predicate function is this. And you go assert q and you go eval. Right. This will be interesting. Yeah, I've not done this before. Let's see. No. Okay, what happened? Missing a bracket. Sure. Hey, right, so we should see our CSV output down here somewhere now. Dun, da, 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 da. There it is. Okay, then cool. You know, neato. But why is this? What's this error all about here? What's this? Oh, it's because mapping failures. That's right. Yeah. Okay, cool. Yeah, I think now is a good time for a commit. And then I think I'm going to deal with return values. Because. And then I think I might go back and reevaluate our position with this trace logging versus standard out and all this kind of stuff. So I think we need to look at that and clean that up a little bit, since we decided not to build a UI the other day. Yet. Okay, so what do? We we write the CSV. So write what are these? I mean, we don't really have a good name for these yet. I'm loath to call them placements at this point. So I'm just going to say result. I mean, we didn't even name that record thing, did we? We're just going to say write results to CSV file. I guess this is mapping results to CSV file. Let's have a look at this. So this is what we expected. That's how we say it to do. Then we added the new thing, and then we do the assertion. That's fine. And then we update this so that it's got the new argument. Fine. Everything there is fine. Let's go to the part mapper. So in order to do this, we had to update the part mapper so that it kept the reference to the only part in the case where there was only one rule applied to it. And it's safe to do the unwrap here because we know there is exactly one thing here. But we don't know which applied rule it was. So, yeah. Yeah. That seems reasonable. Okay, we got one too many white space there. Get rid of that. And then we put the part in the part mapping result. This seems pretty reasonable. And then we updated the test to say that there should be a part for these ones and what they were, and for the other ones that there weren't any parts. Yeah, that's pretty good. Then in the variant builder, what are we doing here? We added the new argument, and we use the new argument when we're building assembly variants. And then at the end of the building assembly variant stuff, we, this is build assembly variant. Not sure about the name of this method right now. Doing quite a lot, isn't it? At the end of the building of the assembly variant, which is what we're trying to do, we write the output. We write the match mappings to the output CSV. And in order to do that, create a temporary record. Doesn't really need any other name. And we create a writer, and then we write the placement part mappings. We convert those to records, and then we serialize the records. I mean, it all seems fairly reasonable. Oh yeah, and then we have to ignore the other things that we're not interested in the other places. That actually all seems fine. That seems fine. Okay. Fine. Let's run some tests. There's oh well, okay. Variant builder. There's a warning. Oh yeah. Don't need that. That's better. There's other things we've got to do with the project as well, like set up Clippy and all this kind of stuff. Yeah. There's loads of little things that you need to do, which need to get done. Yeah. Yeah. Hmm. And then, yeah, I don't know. I don't fancy doing that just yet. I mean, clip is one of these things you probably need to set up fairly early on in the process, in the lifetime of a project, if you know the project is going to live around for quite a while. Because if you add it later, you end up with loads of failures straight away as soon as you add it. So I probably need to get onto that at some point. So there we are. Okay. We'll amend that commit with that warning fix, and then we're going to push this up. Right. Now what? The common theme for today, isn't it? Now what? See what I mean? This is why I titled the video, Now What? I don't know. Lots of things. Let's have a look. Got this. Suppose we could draw on here. I mean, we got a mapped placement. Yeah, I mean, we're just writing those basically, aren't we? No, nothing to draw. What's next? Where do we go from here? Let me bring up this. Yeah, still. Yeah. Nothing exciting there. Curious. 0.3 seconds to run all the tests. Nice. That's pretty good. Like that. Although I am on quite a chonky machine here. Hmm. Let's bring up the other files for inspiration. Yeah, why not? Design. Yeah. So, yeah, we were talking about this UI thing the other day, and at some point I do want to get back to doing UIs because I want one. Oh yeah, that was a thing. Yeah. Let's look at that for a moment because this might jog my memory. So what we were trying to do is go. We've got a list of things that are supposed to happen, or could happen, could be mapped, and then somehow we need to choose one of them. And then we've got some rules for like choosing one if it's the only one, choosing one if there's two and it's in a feeder, and then we added the substitution stuff, right? But yes, this is what we can do. But make him stop! Make him stop! So anyone see that Simpsons episode where Bart stays over at Milhouse's house, and he's going, but. It's a great episode. Come on, you can find it. There we go. Right. Oh, it's already open. Close up the tabs. So in this, let's look at this for a moment. What is the user expected to do here? Right. Let's go back to our UI for a moment. It was this unconfirmed thing. Right. So in the case of R1, there are two possible resistors and the user has to choose one of them somehow. We don't have any way for the user to choose one still. What do we do? Is this another rule where you say, for this particular assembly variant, because it is only for the command that you're currently running, it's not for all of the things that you could potentially run forever, because you've got your part mappings which are supposed to apply to all your projects that you're building. But for this particular one, I need to use this particular part. For this particular placement, I need to use this. Now, I can see two ways that you can resolve this. There's two potential rules that I can think of. I'm going to write this down. One potential rule, let's say resolving situations where there are multiple matching parts and either no rules apply or multiple rules could be applied. Okay. So ways to solve this. You can say, if you have a refdes, you say this refdes uses this part. Okay. Or you say, but is it the same? Ooh, that's interesting. I think it might end up being the same. So my thought was, or if you have placement with name X and value X equals, let's just say part A. Right, but what are both of these? What's the commonalities about these? Both of these are essentially both of these. How do you make this as a page? You can do like some. Is it this? Oh dear, I don't know. I need to improve my log sec skills. It's just like a thing. So, right. In both cases, 1 and 2 are essentially placement criteria, are they not? Because in one case, you look at the refdes and you go to a part. In the other case, you look at two other things and you go to a part. And both of these are essentially the same as our existing part mappings, are they not? I mean, they just look like more part mappings to me. But they're not the regular part mappings. They're for this assembly variant. Let's look at the UI again. So what we're trying to do build this assembly variant. So these are essentially sort of like selections or part mappings for assembly variant. So you've got assembly variant part mappings. Let's see if these ideas fit with what we've already built. They probably do. Yeah, I suppose some of the other things we can do as well, just while I'm here, while I'm remembering this, is future. Regular expressions for mapping. Yeah. Okay. Yeah. I know I need this. We haven't done it yet. Okay. Let's go back to the code. So a part mapping. What did a part mapping look like? It looked like this. It's basically you have some criteria and you get a part. And you can have one or more bits of criteria which can do it. And then let's look at what we said. We said ref des x. If you see R1, you use this part. If you see all occurrences of this and this, you use this part. It's part mapping, right? I think it's part mapping. I think I'm sold on the fact that it's a part mapping. It's an assembly variant part mapping, though. So how does this affect our current part mapping process, I suppose? I guess you need to process the assembly part mappings first, if there are any. And then the other ones afterwards. What if, how can it go wrong? What if there are multiple matching assembly part mappings? Aren't you then in the same situation as you were before, where where you said, yeah, I've got a part mapping, but there's now two. Then what's the user expected to do? Is it a prioritized list? Is it an ordered list? And the first one that matches wins? That could be one way of resolving it. When does this occur? Yes. When does this occur? Indeed. That's probably a fair question to ask. Let's look at some prior examples of assembly variants and things that we've done in the past. What do I want? I want IntelliJ. No, not Notepad. I want IntelliJ. Let's see. Okay. Yeah. Okay. So, some projects. No? Some projects. Okay. Let's have a look at Commander Guy's favorite project. Here we go. Here you go, Commander Guy. You're going to like this. Right. So, what did we do when we were building this? Because this thing was a nightmare. Let's look at the top one. Yeah. So these are my job files from my PnP convert tool, right? And some of this is very similar process that we're trying to do right now. So we have a common file, right? And this is the kind of thing that we said to do. So do not place things, because everyone remembers the fun we had with the LDO bypass resistor being accidentally installed, causing the TCXO to be weird things. Yeah, so we've got that to deal with. We've got our do not fits to deal with. Yeah, let's add that to the. So so currently I'm getting a little bit sidetracked, but if I don't write this down now, I will probably forget. Let's say hash to do. Let's say hash to. Why has that gone giant? That was weird. Inclusion versus exclusion for variance, or both. Yeah, okay. Anyway, enough of that. The way that my other tool did it was that everything is included except the specific ones that you say don't include. And sometimes your schematic says TBD on it because the designer of the schematic doesn't know what is going to work in reality, because some things have to be tuned, such as oscillator capacitors. So they have TBDs. Now, and the way I handled this previously was to do what's called a ref des replacement. I haven't yet decided whether I want to do the same thing in this tool or not yet. Let's go back to what we wrote down here a moment ago, because you could say, if you see this ref des, then you get this part. But the problem with parts is they're not very descriptive. Like, if you saw in your build file, your list of things that you're going to do, right? A part number, it doesn't really tell you much. It tells the manufacturer a lot, as in what to give you, what to build, but it doesn't tell you as a human much. It just says part number, great. And part numbers often are sort of like encoded. And to be honest, a lot of the times you don't care exactly what part you're using. You just care that the specification of the part needs to be something, such as this oscillator capacitor needs to be 4 picofarads, let's say. Right? So you don't really want to go from an EDA placement, for capacitor 37 to a part number. You want to go from capacitor 37 needs to be 4 picofarads, 6.3 volts, 10% tolerance, right? So that was the concept of ref des replacements. But ref-des replacements are a bit funky because they apply to the EDA tools information. So every time you add support for another EDA tool, you then have to have another way of doing these ref-des replacement things, right? But it is what it is. I think I don't know of any. I haven't yet come up with any other options there. Like, do you do it before you actually normalize it? I mean, at the moment we've built all this stuff around non-normalized things, and we're doing our part mappings on non-normalized stuff. It could be that we do these ref-des replacements on the normalized things. We don't really know what a normalized thing looks like yet. I mean, the normalized thing doesn't really. I don't think you can do it on the normalized thing. Because when you normalize it, it's going to be a lossy conversion because each EDA tool has different ways of specifying things. So essentially, you need like an EDA sort of like description field, which has got the name and the value combined in it, and perhaps trimmed or with a dash or a slash. And then if you haven't got a slash, then is it the name or is it the value? You can't go from one thing to the other thing. You can't go backwards with this stuff. So, for instance, a fiducial, they don't normally have a name or a value. They normally just have a pattern. They're a real pain. Test points, they normally have just like a ref des like TP1. Occasionally, they have a name like 5 volts or something, but they don't need to because they're normally just attached on the net, and then you don't need to name them a lot of the time. So if you were to convert like a fiducial or a test point into a normalized placement, you can't recreate the EDA thing. And I don't think you really want to be matching ref-des replacements on the normalized value. So let's not. So we've got ref-des replacements and we've got do not fits. This is an old list. Do not fit. And AKA ref-des replacement slash EBD. So given that, let's reevaluate what we were thinking about for this. If we had ref-des replacements and do not fits, support for those things, what situations are you going to be in where there are multiple matching parts and multiple rules or no rules apply? Because if you've got a EDA file and it's got some part in it that say matches 2 parts, let's deal with that one first. What would you need to do? No, I think you still need to map it to another. You still need to map it to a part. So I still think we need. I still think we need these, regardless. Hmm. Hmm. Interesting. Okay, so we have. Let's just make that a to-do. Fine. So this is what we've got on our little list right now. Before we're done with this, going from an EDA to a placements file. In terms of just like working out parts and so on. And then, you know, we're going to have to deal with all the analyzation and all this kind of stuff. And at that point, I'm really going to want to have a user interface. And display Gerber files. And oh, there's loads of exciting stuff coming up. Oh, it's going to be good. It's going to be good. Okay. I think what I'm going to do is call it here today. And then we're going to... I'll probably do like a bit of this later. But I'm getting hungry. It's coming up lunchtime. 12 o'clock here. Yeah, so I think I'm going to call it there, and I'll work on one of these, then I'll update you as to which one I did, and then after I've done that, we'll work on another one. So there we are. So just remember, folks, it's only software. How hard can it be? Find out on the next one.